Okay, so again, you have two options of how you would like to generate your graph. Now, it's set as a restriction that this needs to be a sine graph. Again, this is the start point, must be the start point. Your end point will be different for each of you, and you'll be deciding on a point where it doesn't matter, if this is where your polynomial function is, it can be anywhere within 15 minutes of that function or before it, depending on who you want to win your race. Okay, so if this was, 2 hours, and they could finish at 2 hours, 10 minutes, and then you could have your exponential function finishing at 2 hours and 5 minutes, doesn't matter, whatever you want. Okay, so the thing that you need to think about while you're sketching your functions or generating your functions is whether or not you want it to have a shape where it goes like this, so it's half of a sine function, or whether you want it to go like this, which is a quarter of the sine function. Now, both of these ones touch 2 points. Okay, if I was to draw the rest of the function, this one would still be a sine function, and that would be one full phase of it. For this one, it just means that it's going a little bit more, and that would be one full phase of it. You could also choose to do this section between here and here of the sine function, but you'll have to generate that one on your own. Okay, so the general formula that we use for a sine function is y equals, in my case, I've reassigned the values on my graph because I've labelled it because I'm an excellent student. So dt is equal to a sine bracket b bracket x plus c, close bracket, plus d. Be very careful with your brackets when you do this. If you miss this one in here, it means something very different. Okay, so first thing we're going to do is we're going to identify our amplitude. Now, if my graph looks like this, the amplitude is the distance from the middle of the graph, from the center all the way up. Remember, you've got a cheat sheet that's got some definitions on there as well if you want help with your language. So in this case, if I'm going to write it out as a formal formula, max minus min divided by 2, which will be 8 minus 0 divided by 2, which is 4. Our d value, or the equilibrium value, is going to be the max plus the min divided by 2. This will return to you the center of the graph. So in this case, they've worked out to be the same. We're going to say that this is going to be, now you have to decide whether it's a positive sine function or a negative sine function. The way that we're going to determine it is I'm going to think about if I took this spot here and I moved it back. So what is it doing from this spot? Because that's going to be my phase shift right there. So from this point, it's starting from the middle and going to a max, which would make it a positive sine function. Now we're going to do the phase shift. So in order to get the phase to shift back, I want to move this thing across 10 spaces. Wait, that could potentially be incorrect. I want to move this thing back halfway. So the halfway point between this 10 and that 0 is the 5, which means to get it back, I have to shift it by -5. So the phase shift, or our C value, is going to be -5. The last one I'm looking for is B. Now, B relates to the period, so that's going to be 2 pi over the period. So for it to do one full phase, or one full period here, we're going to have to do double the x-coordinate here. So it took 10 spaces to get to here, so for one full period, it's going to take 20 spaces. So that's going to be 2 pi over 10. Okay, which will simplify to, that should be 20 because it's 2 lots of the 10. Pi over 10. Okay, all that's left to do now is to state my formula. So therefore, dt is equal to 4 sine bracket pi over 10, bracket, x minus 5, bracket, plus 4. Okay, and that's how I've generated the equation for this looking graph here. Now, again, up to you which one you want to do. It's much of a muchness. It's just more about you evaluating why you've chosen one after. So state some reasons why you think that that's the better model. Okay, because part of your assignment is to explain why these models are appropriate or are not appropriate. Okay, now we're going to deal with this one here. So we're going to start again with our amplitude. So in this case, remember, amplitude is the distance from the middle to the top. So our amplitude now is going to be 8. Now you could use your max minus min formula again. It'll just be max, which is 8, minus the min, which is negative 8 over 2. So 8 minus 8 over 2 is going to give you 8. Okay, our d value is going to be 0 in this case. Again, you could apply the formula using 8 and negative 8 as your max and your mins. Our function in this case is going to still be a positive sine function because we've started in the middle and we're going up. There is no phase shift. And our b value is now going to be 4 lots of the 10 because it takes 1, 2, 3, 4. So it's going to be 2 pi over 4 times 10, or 40, which will cancel out to be pi over 20. So to write that as our correct formula now, dt is equal to 8 sine pi over 20, bracket, x, bracket, and we don't need to put plus d on the end because d is 0. And that is how you generate your sine function.